Okay, the first thing I'd like to do is to give you another example of solving or integrating a definite integral that has u-substitution involved, where we're going to completely change the integral into a new variable u, including the limits of integration. So we want to take care of these limits of integration. Okay, the first thing we're going to do is go ahead and identify what our u should be. Here, a good choice would be our inside function, x cubed minus 5. du will then be 3x squared dx. And we're using our choice of u to determine our du, just taking its derivative with respect to x and then putting that differential up there rather than down here. Du dx is 3x squared, and the dx gets brought up here. Since there's not a 3 up here, there's a 2, but not a 3, we're going to bring the 3 over to the left side by dividing by 3. Both sides, we get 1/3 du is equal to x squared dx. We look up and we see we have the dx factor and the x squared factor, so that's good. It looks like we can go ahead and change to the variable u now. Leaving the limits of integration off for now, let's go ahead and bring the 2 out front from here, and then replacing the x squared dx with 1/3 du, we get the 1/3, which will bring out front, and the du will be inside. And then u is x cubed minus 5, so that replaces the x cubed minus 5 inside there, and we get u to the 7th. Now, all we're left to do here is to figure out what the limits of integration 0 and 2 should be in terms of the new variable u. Remember that the limits of integration are values of the variable given by the differential. So what we want to do is figure out if x equals 0, what would u be equal to? Well, u is defined as x cubed minus 5, so we put 0 in there. We get 0 cubed minus 5, which is a -5. So we put that -5 as our lower limit. -5 is the value of u when x is 0. Okay, similarly, when x is 2, we know that u is equal to 2 cubed minus 5. Well, 2 cubed is 8. 8 minus 5 is 3. So we put a 3 up there, and we've got our integral now completely in terms of the new variable u. We will not need to go back to x since it's a definite integral, and we're interested only in a number result here. So we can integrate this. We get 2/3 of u to the 8th over 8, evaluated from -5 to 3. Now let's go ahead and bring this down below and see we get 2/3 of, I guess we could have put the 8 out too, but 2/3 of 3 to the 8th minus a -5 to the 8th, and let's bring the 3 out here, so we get 1/8 times 2/3 of this difference. Now let's see, that's going to simplify a little bit. We get 4 down there, that's 1/12 of, these are fairly large numbers. Let's see what we come up with here. 3 to the 8th is 6,561, and then 5 to the 8th, that negative sign is going to be taken off by the even power here. 5 to the 8th power is a very large number, 390,625, fairly large number, I guess. Now, doing that subtraction, 6561 minus 390,625 gives us a -384,064, dividing by 12. It doesn't come out even, but it gives us a number that we can write down here, -32,005 and 1/3. So that's 0.3 repeating there. That's probably good enough for our answer here, mixed number, though it is. And we see that we didn't have to go back to x. We just went through directly using the u and using the new values of the limits of integration. Please try to do this as you do problems in your exercises that involve substitution method and have the limits of integration involved. So definite integrals using substitution.